Hey everyone, welcome to the shop. So a couple of videos, if you guys stayed all the way to the end, you saw that I picked this thing up. I picked up a 2GR-FKS. So this is Toyota's next generation, current generation 3.5 liter V6. And I'm trying to make some room in the shop for Project Evie. This thing's got about 10,000 miles on it. Out of a Sienna, but it has been hydrolocked. So before I tuck it away into the corner, I want to figure out if it's going to be possible to get this thing back into a running condition or not. So let's do that today. All right, so before we get into new stuff, let's do a recap of the couple things that we talked about last time, because I know that some of you guys are going to be watching this that didn't watch the end of the previous video. So first things first, my 2GR-FE flywheel that I sell at frankensteinmotorworks.com, in stock by the way, will fit. So the bell housing appears to be, the bolt pattern on the crank appears to be the exact same as a 2GR-FE. I won't put the other bolts in, but we're good to go there. So that's positive. Next thing, as you can see, this is the timing trigger wheel on the motor. It used to be in the crankcase, and now it's back here in the bell housing. I'm not a fan of this change. Maybe we'll see something in the oil pump as to why they made the change, because there was space there before, and best I can gather, this motor is dimensionally the same as before. The only advantage that I can see at this point is this is serviceable without moving the air conditioner compressor. On the 2GR-FE, you have to pull the compressor off to be able to get to this. And they are known for going bad. So maybe this is simply a case of trying to reduce warranty hours for when those do go bad. Maybe. I would imagine there's probably a bigger reason, because it's not like they fail that often. But that's it for this side of the engine. Oh, and by the way, it looks sloppy, but it's a super tight fit on the actual bolts that go in there. So maybe only about a degree of slop. It's not going to affect the timing on your motor. On this side, as you can see, this thing has integrated manifolds, and it still has an oil cooler in roughly the same location, but it's a completely different design. Of course, the lessons learned from the 2GR-FE going from the rubber lines to the all metal lines already, so there's no point in upgrading that. Also, speaking of upgrades, you'll notice there's no more external VVTi oil lines. Those, I haven't popped the valve cover yet. We will before the end of the day, but I imagine they're going up through the head. These are the VVTi solenoids. They've changed those. I don't think there was a reliability issue with them before, but since it went up to the valve cover, this avoids needing any pressurized stuff in the valve cover, and since it's plastic, that probably just increases reliability. So, and I bet this probably shaves a pound or two off the motor, probably nothing significant. Let's see, what else? The other noteworthy thing is you see these two fuel rails here. These two as well as these two, it is direct fuel injected now. Direct and port. The port fuel injection is kind of interesting. Actually, here, let me grab the other camera. So you can see it's a sheet metal manifold, and the advantage there is that actually acts as the pressure damper. This whole thing will pulse up and down in order to even out the fuel pressure. So it lost the pressure damper that used to be located right about there. And actually, speaking of which, the fuel input for the rail has moved. It used to be right here. Where'd it go? Oh, where'd the fuel input go? Well, I think we're going to have to see when we pull the intake off where the fuel intake went. I bet it's probably shared off of the high pressure system, maybe. I bet, maybe. Yeah, how's that for confidence? All right, the other thing I want to do, and this is something we didn't cover last time, is I want to see if the bell housings fit. Right? See if we can use the same transmissions. And let's see which holes connect through. So, okay, and we'll just mark them right here. So that one's good. That feels like a little bit odd hole, but that one's good. And we'll check in a second if they have threading. Okay, this one definitely is good. No go on that one. No go. Got something here. This is the one that's generally not threaded on the 2GR-FE, so we'll have to see about that one. Okay, we've got one over here. And it looks like, so this is an earlier bell housing. It doesn't have the extra holes on there. So the two on the bottom don't align, but I'm gonna go ahead and bet that they do align on the later bell housing. All right, so this is an early bell housing. It looks like probably 4 bolts, maybe 5 if this one is threaded. Let's take that off and check the threading on the ones that are there. Okay, so as we can see, this M12 is threaded. This one, okay, this one felt funny. There's nothing there. This one is threaded. This one is aligned, but again, we'll need a helicoil, like the old-fashioned one. And this one actually goes the other way, and there is a thread in the transmission. So we've got 2 way at the bottom of the block. And yeah, I'd certainly like to see more, but that's acceptable with an old bell housing. All right, let me grab a newer bell housing and we'll see which points it adds. All right, so let's see. Yes, it does. So for some reason I want to say this is not as late as they get. I think there's, is it up here or something? I think I'm missing a bolt hole on this, but either way, this is what I had in the shop. So it does add, well, here, let me just take it off and show you. So the later bell housing adds these, which it's nice. That gives more of a 360-degree support situation going on. I really think that this one is available on some of them, some of the later ones, but it doesn't matter. Even without that one, it's still more than acceptable. All right. Oh, actually, let's get the EB60. So first thing you see is that these two here are in the way for a 2GR-FE as well as a 2GR-FKS. And let's see what we can do. So we'll just kind of approximate the position that way. We can see this one matches. This one. That one does. All right, so the EB60 lines up this one. Yeah, let's erase the other ones here. It does line up this one as well as that one, as well as these two down here. And there was a hole here. Let me see if it's threaded. This hole is not threaded, so that doesn't match. So, yeah. 1, 2, 3, 4, 5, 6. So, 6 bolts. It looks like 2 M12s, actually 3 M12s. It looks like 1, 2, 3, 4 M12s and 2 M10s. So, pretty happy with that. All right, so the FKS is compatible with the early E153, the late E153, as well as the EB60. And because of the same part number, the EB62 also. And on the other side of the motor, we can see a couple things. First of all, it's got, I'm not sure if this is electronically controlled thermostat or it's a coolant temperature sensor. Since the coolant temperature is supposed to be on the other side, I bet that's an electronic thermostat. Yeah, neat, as long as it's reliable. Otherwise, it's expensive. The other thing we can see is the old bolt pattern right here lines up. But unfortunately, this, and this are too far in, I think. I think that's the issue. It's possible that these two are too far out, but I'm pretty sure it's these that are too far in, which means just some washers behind that to space these out, and it's good to go. The water pump, not sure if it's the same part number, but it sure looks like it. Well, actually, this area up here might be different, so maybe it's a different part number, but it sure looks to be the same design. And, oh, there you go. That's likely an oil level sensor. Interesting. Well, let's put it on an engine stand and see just how bad our motor is hydrolocked. I'm hoping, really hoping, that it's just one bent rod. And that should be pretty easy to get. We'll put it in and we'll have an FKS motor. Honestly, I don't even have a project for this in mind, but who's going to turn down a 10,000 mile motor for free? Especially when I know eventually I will have a purpose for this motor. So, all right, engine hoist. All right, so I've got the motor flipped over because I want to get an idea of how careless I can be with the disassembly of the rest of the motor, and that'll depend on if it's salvageable or not. So first, we need to figure out why it's not turning. Well, she did go for a swim. We got a milkshake. That's fine. That's not necessarily a problem. Well, there's our first sign of damage. And here's our next one. So now we're left to just hoping that the bore is going to be clean. So hopefully it's salvageable. All right, well, that's not what I was hoping to see, but there's still a chance. It's a much smaller chance than what I thought it was before, but there's still a chance. You're kidding me. Oh, that's giving me hope. Let me set this down. So let me give you a different point of view here. You can see, let's get the light in. You can see there's just the tiniest scuff mark right there. And it's touching there. And way down there, I'm not sure if you can see it, there's a little dent in the block. Nothing of concern. If the cylinder wall is somehow not scored, and that's the only problem we've got, we just won the lottery. Okay, I can't feel anything, but I'm only able to touch the very top of that, well, very bottom of that bore. So let's pop this out. It'll give us an opportunity to look at the bearings in there. And then we get the drip tray, flip the motor over, and I guess we're pulling the rear head, the number one head, off. And we're gonna see what that looks like. That's not great. That could just be from the oil film breaking down. Yeah, it doesn't look like any debris got in here. So for the time being, I'm going to assume that that's pressure that was applied at some point, somehow. Yeah, I know, super precise. But let's get the drip tray, flip that over. thing's maybe a little too far off balance. Whew. All right. Ooh, look at the size of those ports. Well, that's exciting. Ah, there's the fuel rail input. There's probably something that tees both ways here because this is the high pressure input. All right, and also there's a fuel pressure rail feedback. That's nice. I don't know what the flow rate is on those injectors, but if you look, interestingly, they added a feature to make it so that the angle is more exact than it used to be. A couple more things. It looks like there's a lot more of these little plastic wire management things. That's likely just long-term reliability thing, which is great because the 2GR-FE was an amazingly reliable motor to begin with, so these little touches, just a little extra nice. So let's see. It looks like the direct injectors are onto the head, not on the block. So I think that's going to have to come out next. There it is. Nothing special here, just a cam-driven vacuum pump. Though it does mean right off the bat that any aftermarket cams for the 2GR-FE will not work with the 2GR-FKS. There might be other things. I wouldn't be surprised if the VVT channels are different anyway, so might not matter at all, but we found our first thing that's going to stop you. So this is interesting. This must be a safety thing. There is a massive shield on top of the high pressure fuel pump, probably so that in an accident this doesn't get damaged and spray high pressure fuel. It makes sense, but look at this thing. It's what, 5 millimeters thick? So there's a reason for this. It's not just a little shield. All right, and direct injection, of course, requires a high pressure fuel pump. And that's this assembly, which, yeah, got a little of that milky oil. Just the cam pushes on here and makes high pressure fuel. You're gonna make me take those off. All right, the studs have to come off. Not sure what the point of an alignment stud is here, if they have to be put in afterwards. It's definitely, unless I've got the disassembly order wrong, this definitely should have been just a bolt. All right, next thing is the valve covers, both of them. Because the wonderful thing about a 2GR is to get to the timing cover, you have to take both oil pans off and the valve covers. That is one thing that I hate and that they have not changed. Yes. We still have spray bars. They're plastic this time. Nothing wrong with that. Reusable gaskets, which I love. Oh, that'll literally buff out. Valve train looks pretty much the same as it did before, and yeah, we're gonna have to take the cam carriers off to take the head off, so that's fun. All right, other valve cover. All right, and no signs of rusty cams on this side, so great. So yeah, actually, it looks like even if that is rusty, it's just one cam. Cams from Toyota tend to be about $300, so If it doesn't buff out, that's still not a deal breaker, which is awesome. Awesome, awesome, awesome. Now we need to take the front stuff off the front of the motor. And I can say for sure now that the water pump is different. This outlet definitely looks different. Oh, neat. The AC bracket is not part of the tensioner assembly anymore. Actually, that would make the spider swap easier. But I think there's other things in here that would make the spider swap harder, so I'm not about to change path. Yeah, there's got to be a grenade pin in here that probably locks it right there so that it's not a pain to remove that. There's no way Toyota would have somebody on the line doing that with their fingers. All right. Oh, what the hell, Toyota? So there's still plenty of room right here for the trigger assembly. Toyota just moved it because they wanted to move it. There's probably some service reason for it. All right, well, not a big deal. Give it a little pry just in case. I don't think this is the problem. Oh, never mind. That was the problem. I'm glad I was holding. Let me just start gluing it down. Oh, no. Yeah. Let me bring you guys in closer, but I might have sat with the water in the block for too long. So, you see that? You see that? That could be bad news. But, let's keep taking a look. These blocks don't have a heck of a lot of room to be machined, but they do have some. Like about 1/10 of a millimeter. All right, let's see if we can get that piston out. All right, let's turn it back up and take a look at the bore. See what we got. So, shockingly, the rod really did not hit anything. That's amazing. You know, that's not great, but that should actually all clean up. Neat. While we're in here, these look like beehive springs. Could be a potential upgrade for the 2GR-FE. I'll have to check what the spring rate is. Actually, the camshaft is bigger on this motor, so they probably are bigger. All right, so we got this whole thing disassembled, and really interestingly, honestly, I wasn't expecting this. The only thing we found for damage is this connecting rod here. You know, half is here, half is here. Plus there was that tiny little piece. This made the tiniest scuff in the block. Nothing that would actually cause any issues. And the only thing that the connecting rod punched through is this right here. Which means had this been caught, had this been taken apart as soon as this happened, this motor would have been completely rebuildable with a new connecting rod, and I'd probably put a new piston in it just for the sake of comfort, but there's nothing I can see that's wrong at all with this piston either. It just tried to compress some water, and turns out you can't compress water. And you know, these things are even higher compression ratio than the 2GR-FEs, so they're going to put up with that even less. This lining here that's sprayed on, it's just an iron lining, and it depends at which motor you look at from Toyota, but some of these, they spec that they can't be rebored, and some of them spec that they can be rebored up to 0.1 or 0.13 millimeters, which is tiny. Generally, the smallest rebore that you do is about 1/4 of a millimeter, so it would take a special shop to do it, but thankfully I live in Indianapolis, and I've already had one of these rebored, and the shop was able to do it 0.05 millimeters. Not one of these, it was actually a 2AR, but it's the same type of spray-on sleeves. So this block is salvageable, but interestingly, I looked at all of this, and I'm not going to drag it out here because, frankly, it's heavy and it's in the other room. But this block, all of these dimensions up here, I didn't check everything absolutely thoroughly, but best I can tell, this here, this interface here, and of course the other head, is exactly the same as a 2GR-FE block. So in theory, I could take all of the 2GR-FKS parts that I took off of here, and I could just use a good 2GR-FE block and run it. Now, of course, that would have a lower compression ratio, and it wouldn't have these special pistons here. So to do it right, you'd probably actually want to run the 2GR-FKS pistons, which then you'd have to measure, make sure the connecting rods are the same length so that your compression height is the same. Otherwise, you might end up with a different compression ratio than you intend. But there's definitely some interchangeability here. Now, the crank position sensor moves from the front on the FE to the back on the FKS, but there's space up here for it. I'm not actually seeing any kind of limiting reason. The crank has a different part number, but I suspect it's simply because it's missing the trigger wheel here, because otherwise the dimensions, best I can tell, without busting out the micrometers or anything, are identical. So I'm not 100% sure what I'm going to do. The other more important reason that I'm actually hesitating to rebuild this thing is you may have remembered at the beginning, well, actually it's not that long ago for you, but I mentioned that these ports looked absolutely huge, right? This is the lower intake manifold. But what you have to realize is that these ports are on an angle. This is not a true cross-sectional area because they're crossing here at, well, I mean, you can see, right? The ports are just not, they're sloped perfectly into it. Whereas the 2GR-FE, the ports actually come out at an angle and they're going vertical by the time they hit this interface. So without getting too precise about the measurements, these ports, if anything, they're actually smaller. Now, smaller can sometimes actually make more power. The velocity actually does matter. But when you put bigger cams, you generally want bigger ports. So even if the velocity is better to make better power with the factory setup, this might run into some other issues. Basically, what I'm trying to say is I think all of the extra power, because this motor here is rated to 295 horsepower, whereas the 2GR-FE is rated to 269. And I think that 26 horsepower difference just comes down to higher compression pistons and longer duration cams. This motor has longer cams. From everything I can see here, there's just not an advantage to going to this motor. Now, we won't know, we just won't know until somebody actually does something with it and finds out. But at this point, right, we're making over 300 wheel horsepower with the 2GR-FE. So we're already making more than this by, well, I mean, we're making 5 to 10 horsepower more to the ground than this thing is rated to the crank. So I expect that this thing would see very similar gains, and with the port as well as a direct injection, if you spend a little extra money and get a fancy aftermarket controller that can do both, there's some room for some extra power there. Right, it's more detonation resistant. But the differences are minute. Considering how expensive these engines still are, I'm going to go ahead and say that they're not really worth exploring. The biggest thing that I got super excited about is the 2GR-FKS goes in the Tacoma these days. And the Tacoma still has, it's one of those vehicles that still has a manual transmission option. So I got all excited. Does that mean that there's now a longitudinal rear-wheel drive transmission available, well, actually four-wheel drive too, available for the 2GR-FE, right? Because the block is the same. This interface is the same, this interface is the same, this is the same. I didn't check the oil pan, but I bet it's the same. But I checked the part numbers. The Tacoma part number for the block is different than all of the 2GR-FKS, the other 2GR-FKS applications, which are all transverse. So it's probably still the same difference that we used to have in the previous generation. The longitudinal block has just a completely different bell housing bolt pattern than the transverse block. So I got all excited for nothing. I still think if we go digging in the parts bin for Toyota, probably will find a bell housing for a longitudinal rear-wheel drive application that will bolt to 2GR-FE or the FKS for that matter. I just haven't had the reason to look too much yet, so maybe someday. So what I'm going to do from here, so that I can make my decision later, is I'm going to take some of this fluid film here. This stuff's pretty fantastic for preserving things long term, and I'm going to put all the parts in baggies. I'm going to try to purge all the water that I can from here, and I'm just going to drown it in fluid film. And that way, if in 6 or 12 months I decide, hey, I actually do want to do something with that 2GR-FKS, it will not be in any worse condition than it is now. But as it stands for the moment, I think the only thing that would be worth doing is taking the 2GR-FKS heads, well, just one of them, and having it flow benched to see if those ports actually do flow more, possibly with the mid intake as well as the upper intake manifold, because they all get used together as a combo. So that does take time, that does take money. Not a ton of money, not a ton of time, but we'll see. I haven't fully made up my mind on if I'm going to do that or not yet. So thanks for sticking around with this minor detour. I know some of you guys were probably expecting an EV video, the next video, but EV is going to take a whole bunch of space in the shop, and I wanted to get this out of the way, and because otherwise it would have just been sitting there for even longer, and I wouldn't have been able to get around to it because there just wouldn't have been space in the shop. So next video, I'm probably going to see about confirming the 2AR to E153 transmission fitment. The more I think about it, the more I think I'm going to go with the E153 on EV. It's probably not going to be the only transmission I put on there, but I think for now it's the right choice. The E153 has a lot of drawbacks, but drag racing is really one of its strong suits. So since it bolts right up, 99% sure, it just seems like the easy way to go for now. So anyways, that's all I got. I'll see you guys in the next video. Have a great day. Bye.